Hello class, and welcome to Review for Exam, Unit 4 or Lesson 4 of the review. Today we're going to be taking a look at exponential functions. So to start off with, ladies and gentlemen, let's deal with the exponent laws. These are ones you learned in grade 9 and 10. So remember the multiplication rule: when the base is the same and you're asked to multiply, you add the exponents. When it's the division law and the base is the same, you subtract the exponents. When it's a power of a power, or you see one exponent raised to another exponent, you're going to multiply the exponents. And then we got into what is called negative exponents. Okay, negative exponent is where you got b to the negative m. It's improper to leave a final exponent or final answer in exponential form where the exponent is negative. So always make that positive. If you have a whole number, for example, 5 to the negative 1, that becomes 1/5. But if you have a fraction, ladies and gentlemen, and it's expressed to a negative or raised to a negative exponent, you flip the fraction and make it a positive exponent, like it says here. All right, next we learned the zero exponent law. Anything raised to the exponent 0 is 1, but you've got to be careful about negative signs. For this first example, the negative is part of the base, so the answer is just 1. The second example, ladies and gentlemen, the negative is out front, so it's really negative 1 times 5 to the 0 because there's no bracket in it, okay? So that's going to equal negative 1 as an answer. Whereas the third one has a negative out front and negative in the base, so this answer would be negative 1. Okay? Lastly, we learned about rational exponents. Rational exponents is where we have a fraction as exponent. Okay? And remember, ladies and gentlemen, that when you're taking a look at this, the top part, or the m part, if you're taking a look here, the m is the exponent. Okay, and the n part is the root. And I wrote, before you write that down, folks, I wrote it right here. Okay, just want to make sure you're aware of that. So the common thing that we want to do, folks, is when we're given an expression in rational form, we can switch it to exponential form, or we can switch it back. So for example, if I give you an example and say to solve 8 to the 2/3, you would want to take it from exponential, put it into rational form, which means, hey folks, when we take a look at this, the 2 is the exponent, so it goes out front, and 3 is the root, so I'm taking the third root of 8. Okay, so third root of 8 is 2. And you square it, so that's going to equal 4. Okay? Taking a look now at graphs of exponential functions, so we use the base formula y equals a x to the n. And when we talk about growth versus decay, it's growth if b is greater than 1, and it's decay if it's between 0 and 1. Okay, so based on the expression given, a good example of a population growth is when you get bacteria and they multiply and multiply and grow, and you can get sick because of an infection or a virus because of that. And the most popular option of decay is, I would say, depreciation. So if you get a car brand new, over the years it decreases and decreases in its value. All right, so just remember, folks, when you've got an increasing function, if you're drawing that, it increases as you go from left to right. Okay. And if you have a decreasing function, ladies and gentlemen, it decreases as you go from left to right. Remember when you're drawing these, ladies and gentlemen, that when you graph these, you're going to have what's called an asymptote. Okay? So we're going to graph some of these functions in a second. So based on this graph, if I've got x and y, and I'm going to graph both y equals 2 to the x and y equals 1/3 to the x, I'm going to be aware that there's an asymptote here at the x-axis. So the asymptote is y equals 0. Okay? So let's take a look. How would we graph this, ladies and gentlemen? Well, set up a table of values to start with. Go x and y, and because we want some negative and some positive values, we'll go like this. So plugging that in, I start with my 0 always. So 2 to the exponent 0, that's 1. 2 to the exponent 1 is 2. And 4. I always look for a pattern as well. Or 2 to the negative 1 is 1/2 and 1/4. Okay? So let's graph that, ladies and gentlemen. So if I have 1, 2, 3. Okay, so at 0, it's going through 1. At 1, it's going through 2. And at 2, it's going through 4. And then it's going half at -1 and a fourth. Okay, so if I draw my line, nice curved exponential, and I'll call that y equals 2 to the x. That is an increasing function. As it goes from left to right, it's increasing. Okay. Likewise, I'll change colors and I'll use a green for the decreasing function. Going to use the same values, -2, -1, 0, 1, and 2. Start with 0. I know that's going to be 1. And if I go, if I sub in x equals 1, that answer is going to be 1/3. If I sub in 2, it's going to be 1/3 squared, which is 1/9. Okay. Likewise, I do the other ones. You got to watch here because you got those negative exponents. So you flip them. So that's really going to be 3, and it's really going to be 9. So when I plug this, I start with my 0 and 1, and then when it's -1, it's going to be 3. -2 is going to be 9, way up here somewhere. When I've got x equals 1, it's 1/3, and it's 1/9. So this is an example of a decreasing function. And this is y equals 1/3 to the x. All right? Cool. All right, transformations and mapping. Again, the mapping sequence, which is here below, will be provided on your exam. You'll get the copy of the exam sheets, exam formula sheets, so you know exactly what to expect. But this is on formula sheet. Okay. And what you need to remember, folks, for transformations is that when you're dealing with exponentials, ladies and gentlemen, all this bracket stuff in here, when we're dealing with an exponent, or sorry, when we're dealing with exponentials, this is all up in the exponent when exponential. Okay? So for this unit, that's going to be all raised up. I'll do an example in a minute and I'll show you. Okay? Remember, guys, that A and K deal with your stretching, compressions, and reflections, whereas D and C do your translations up, down, left, right. Note that A and K deal with the horizontal movement, therefore they affect the movement on X, and A and C deal with the vertical movement, that's why they affect the movement on Y. That's why in the sequence you see, the mapping sequence, you see those affected by those certain variables. All right? Awesome. All right, let's do an example here, folks, just of the transformations and what would happen. Okay? So say I gave the example y equals 3 bracket 1/2 all raised to the 4x plus 4 and then minus 7. Okay? First thing we need to remember, guys, whenever we're dealing with any types of transformations or functions is k factored out. Okay? Don't forget to factor out k, because that affects your d value or your translation left and right. Okay? So taking a look here, notice that k is not factored out, so we've got to do that. So y equals 3 bracket 1/2, and then we're going to take 4 out, and we're going to have x plus 1 all up in the exponent, and then subtract 7. Okay? If we're trying to figure out our base function, okay, so to figure out our base function, you strip away, guys, if you're not sure, strip away A, K, D, and C. So if I get rid of the -7, I get rid of the 3, I get rid of the K, which is 4, and I get rid of the 1, what am I left with? Your base function is going to be y equals 1/2 to the x. That's the only thing that's left over. Okay, and then we can identify from our equation that A equals 3, K equals 4, D equals -1 because remember it's x minus D up here, so it becomes negative. I'm going to fix that up so it looks better. Okay, and C equals -7. So from that, ladies and gentlemen, you could either map it or describe the transformations, so depending on what the question says. So now that you've identified A, K, D, and C, you can either map it, make sure you know how to do that using that sequence, or I could ask you to describe transformations based on each of those letters. Okay, and if you're mapping or you're asked to graph it, ladies and gentlemen, just remember the key to the asymptote for this one. Okay, asymptote is affected by your up and down movement, so y equals c. So in this case, y would equal -7. So the asymptote would be moved down 7. Okay? All right, if you wanted to see an example of mapping, I'm just going to take this exact example, and I'm going to flip 2 pages, so it'll be there for when you get to it. So 1, 2, and here is mapping using the parent function, showing the mapping sequence. I just didn't draw the graph with the points, so I wanted to provide that information from you. Please see me if you need any help with the domain and range on that, but that's there for you to study later. I just didn't want to spend a 20 minutes lesson on the mapping, because most people have mastered that by now, but by all means, come and see me if you need some help. All right, I think we're at the bottom of the first page. Let's see. Yep. So let's go to the second page of the review. Flip it over. Now we're going to be comparing table values. So this is talking about your different forms of the, I apologize. Let's go back for a second. Did I forget to do something in here? I forgot to actually write in these answers, so I apologize. So let's figure these out. So I said to add the exponent, so it should be b to the m plus n. I apologize, guys. And over here it should be b when you subtract, m minus n. And this should be b to the m times n, or m times n. I apologize for not filling those in. Now we'll go to the second page. Sorry for the flip-flopping. Okay, comparing table of values. Okay, you should be able to tell from a table of values, from an equation, and from a question and a graph which functions are linear, quadratic, or exponential. Okay, based on a table of values specifically here, we know that it's linear if the first differences are constant. Okay, it's going to be quadratic if you're given a table of values if the first differences are variable and the second differences are constant. And it's going to be exponential if both the first and second variables are variable, but we do the y ratios being constant. All right. Awesome. Now we're going to get into what's called applications. Cool. Applications are where you see word problems about, you know, giving medication and the rate of the medication wearing off and stuff like that. Or when you're taking a look at finances, that's another thing that can talk about here. Population growth, a whole bunch of different questions come into play. This is how you see exponentials in the real world. Okay, so we use the formula y equals a b to the x, okay, where y is the future amount or your end population if you want to talk about that. X is the number of growth or decay periods, could be number of years depending on what we're talking about. A is your initial amount and B is your growth or decay factor. So just remember that your decay factor is different than your rate. Okay, and here's the relationship between the two, if it's a decay rate or a growth rate. Okay. So say the car depreciated by 22%. You would take 100, subtract 22, and you would get 78. So the rates are given in percentages, okay, or fractions. So you would just take 1 and subtract that and get, I think it was 78, I said. All right, great. So taking a look here, often when rates are given, we use these formulas where the rate is given. Just change the rate from a percent to a decimal. Okay, 1's for growth. When you add it, it's for growth. When it's for decay, you decrease it. Okay, so for example, for A, if I said you got a 5% increase over a population that started at 1,000 people, this would be your model you would use. Okay. Likewise, if I said you had initial population of 500 people, but you had a decrease in the population of 20%. So 1 subtract 20% is going to be 0.8. So notice the growth factor, or decay factor in this case, is less than 1. That tells you it's a decay. All right, then we talked about doubling life and half-life. When you take senior chemistry or sciences in university, you will come up with this for sure, okay? So what we need to realize is that you've got to take a look at the time it takes. So it's going to be a specific period of time is given for something to double, okay? And you've got examples of these in your notes. So just remember that if you've got the doubling time, it's t divided by d as the exponent in terms of, okay, how much time versus how many times it takes for that to double. Same with the half-life, h is for half-life. How much time it takes for that to be, that quantity to be cut in half. All right, here's an example. A 120 gram sample doubles every 32 days. Create a model for this situation. So first of all, what do we know? We know the base. Instead of dealing with a rate, it says it doubles. So we know base equals 2. Okay? We also know that our initial amount, which is A, we also know that A equals 120. Okay? So population at whatever time we're going to use equals A, which is 120. Times 2, but then we got to figure out this next part. I'm just going to move this up because I kind of ran out of room here. I'll rewrite it up here. Okay. Now it says that it doubles every 32 days. So for your exponent, you're going to write t for whatever time we give divided by 32. So that's the model for that situation. Next, it says to find the mass after 100 days. Well, that's pretty simple. You just say, hey, let t equal 100. So instead of p at t, you're going to go p at 100 and sub it in, equals 120 times 2, all raised to the 100 over 32 in the exponent. Okay, so plug that in your calculator, ladies and gentlemen, and you should get p at 100 equals 1,046.9 grams. Make sure you put that in the therefore statement, guys, okay? Just don't have room here. And the last question says, how long will it take you to have 500 grams? So be careful. That is your end amount. So in this case, P at T equals 500. So what do we know? We know 500 equals 120 times 2, all raised to the t over 32. Okay, so what we need to do is try to solve for t. The first thing that's in the way here, working backwards, is we can get the 120 out of the way. So we're going to divide both sides by 120. Okay, I'm just going to move along the side here. Okay, so what we end up with is 4.17 equals 2 to the 3 over, or sorry, 4.17 equals 2 raised to the t divided by 3.2. And this is where you sub in values. So trial and error. Unless you know how to do logarithms, you can plug those logarithms in. Okay? That's something out of the scope of this course. If you don't know, that's okay. You'll learn that in grade 12. Okay? All right, but if you don't know logarithms, you're just going to sub in values with trial and error. So you plug in values and start seeing when you get the left side to equal the right side, and you're going to get t equals 66 as an answer. So therefore, it takes 66 days to get 500 grams. All right? Okay, folks, here's your homework, page 108, numbers 1 to 4, 27, 28. Just be aware, guys, that on the next page or two, I've got some answers here to help you. So although we did that mapping one, there are some homework questions listed here if you need some help. Okay, as well as 3 is there too solved for you. Okay, so that's just there for reference if you need some help. Anyways, have a great day, and keep studying hard. Push really hard, guys. I know you can do this. And come and see me if you need any extra help. Okay? See ya.